example of long division. On these, you don't have to do every single example if you think you got it. Just go on. So, I'm going to divide. And here, I'm not necessarily going to write down every step, but negative 4x cubed divided by x is negative 4x squared. Multiply, and you get negative 4x cubed plus 4x squared. Subtract, and you get negative 3x squared minus 4. Divide, negative 3x squared divided by x is negative 3x. Distribute, negative 3x times x is negative 3x squared. Negative 3x times negative 1 is positive 3x. Uh-oh, that doesn't line up here. So you can rewrite this as plus 0x minus 4. That might help you when you go to subtract. So we're ready to subtract. The 3x, negative 3x squares cancel. 0x minus 3x is negative 3x. Negative 4 minus 0 is negative 4. So our answer is negative 4x squared minus 3x. Oh, I'm not done. Am I? That exponent is not lower than that exponent. So step 1 is to divide and get negative 3. So distribute negative 3x plus 3. Subtract, and you get negative 7 for a remainder. So we have negative 4x squared minus 3x minus 3 plus negative 7 divided by x minus 1. Please come with questions about long division on Tuesday. Alright, the next part of the chapter is factoring. Today, we're going to focus on 2 terms and on 4 terms. Now, every factoring problem, you look and see if they have a greatest common factor. Then you file it into 2 terms, and these are your possibilities. 3 terms, and this is your possibility to factor, and 4 terms, and that is your possibility to factor. So, if you need to pause, go pause and write all that stuff down. Alright, so I'm going to look for my greatest common factor in all of these. X squared and 81 do not have anything in common. 3x cubed and 27x, what do they have in common? 3x. So if you divide each term by 3x, you get x squared minus 9. And here, they both have an x in common. Alright, so if you look at every single one of these, they're all 2 terms. So that falls under our second category, where 2 terms can be difference of squares, difference of cubes, and sum of cubes. Today we're going to focus on difference of squares. So if you look at all these are squared. If it was sum of cubes or difference of cubes, you would have x cubed there instead of x squared. So difference of squares, it has to be a difference. So it has to be a subtraction symbol between your 2 terms. Also, your 2 terms have to both be perfect squares. What that means is, can you take the square root without getting a decimal? Okay, so if we look at that first one, what is the square root of x squared? X. What is the square root of 81? 9. What you do, since it's difference of squares, you put x minus 9 and x plus 9. It doesn't matter your order there, because multiplication is commutative. Here, we got x squared, so square root is x. Square root of 9 is 3. So you got x plus 3, x minus 3. This was also a factor. It was your greatest common factor. So we have to write that in our answer, so it just falls down. So x is going to fall down. Square root of 144 is 12 minus x, and 12 plus x. Like I said, it doesn't matter if you do the plus or the minus first, as multiplication is commutative. That means the order doesn't matter. Alright, so now we're going to look at these problems. Our first step is always the greatest common factor. If you look at this problem, I thought at first they were all divisible by 2, but 3 isn't, so that one doesn't have a greatest common factor. This one also does not have a greatest common factor, and neither does that one. 3's, but the 2 is not divisible by 3. So since there are 4 terms, you fall into that bottom category, and it's called factor by grouping. That's the old terminology, or the traditional terminology. We're going to use area models because that's what you're used to. So if we do an area model, this would be our answer from the area model. So I'm going to put that in my boxes of my area model. I just put them in order as I see them up there. So what you're going to do is you're going to fill out the outside of the area model, and that's going to be your factors. So what you do is you look at each row and each column and say what they have in common. So if we look at this row right here, they are both divisible. 2 and 4 are divisible by 2. We got x cubed and x squared, so they're both divisible by x squared. So then we're going to look at this column. 3 and 6 are both divisible by 3. That's a row, not a column, sorry. Here we're going to look at that column, and they are both divisible by x. And this column is both divisible by 2. If we want to check ourselves, if we multiply those two, you get that. If you multiply those two, you get that. You multiply by those two, you get that. And those two, and you get that. If you do, you did it right. If you don't, you did something wrong. So you write this side as a factor, so 2x squared plus 3. And you write your top as a factor, so x plus 2. You could write your top first if you want, and then your side. It doesn't matter because your order doesn't matter when it comes to multiplication. It'll just see your factors. So why don't you try the next two, pause the video, see if you can get it right. So, fill in your boxes. This is the easy part. Now say what your rows and columns have in common. The top row has 3x squared in common. The bottom row, a negative 1. The top column, or the first column, x. The last column, 2. Check yourself. See if it multiplies. It does. Go us. So I'm going to write my top first this time, and then my side. If you did it the other way, it's okay. So let's do the bottom one. In your area model, 9x cubed, negative 6x squared, 3x, and negative 2. So the first row has 3x squared in common. The bottom row, 1. First column, 3x. The last column, negative 2. I'm going to write my side first this time. 3x squared plus 1. And 3x minus 2. And bam, you're done with the second day of notes for college algebra. Come with questions next time about your homework, as well as the notes you just took over factoring and long division. I look forward to doing those problems with you in class. Have a great day.